Hello everybody. Today we have a executable program in C#. This program was inspired by my physics class for university, and the function of this program is to calculate the resultant 2D vector given one or more vectors. It isn't that long of a program at all, less than 200 lines of C# code. Now, some bugs with this is that because of how the sine and cosine is calculated with float values, you can't get 1, -1, 0 properly when you're calculating sine of, say, 90 and trying to get 1 from that. And so I've had to put up with lookup tables for the sine and cosine, specifically with specific angles like 90, 270, 0, 360, etc. So if you try to put in two angles that are exact opposites, particularly angles like 45 degrees, it may not say that they're actual opposites. So if you entered 45 degrees and 50 magnitude with a second vector of 225 and a magnitude of 50, which are exact opposites, then they won't technically be canceled out in the program. It'll come up with some weird math or some weird answers, so just be aware of that. But we could test it out here. So do we have more vectors to add? Yes. Let's do the direction 45 degrees, 50 magnitude. See, we're given the x and y components. Add another vector. Let's say we're going to go in the angle of 270 degrees. So we're going to go 45 degrees is up and right. This is what you would consider north of east, and 270 is just due south. And let's give it a magnitude of half. Now keep in mind this used a lookup table for 270, which is okay. Then we will have no more vectors to add, so no. And then enter. This is an exit function later for the actual exe that I will show y'all. It gives you the resultant components, the direction of it in degrees. You can decide what precision you'd like to show, and the official resultant magnitude. Keep in mind that to find magnitude of a vector, all you're doing is adding up the square of its components and taking the square root of that. So let's go ahead and show this. I have my xe here. We can click into it and see we have yes. I'm going to use the exact same values as before. 45, 50, yes, 270, and 25. And we end up with the same values, and then enter to exit just closes the window. Now what I was mentioning about canceling out vectors earlier. If we have the angle of 90 degrees, which is due north, and let's give it a magnitude of 10. And then we enter due south and the same magnitude. Then it will cancel out, and therefore you just have a point. This is the point where your first vector started as the two vectors canceled each other out. You basically went from point A to point B back to point A. Nothing happened. Another interesting quirk is you can that's what you would consider destructive interference if you were looking at a sine wave versus a equivalent cosine wave trying to interfere. If you were to do, say, due north magnitude 10 and do another due north of magnitude 10, then you end up with due north of magnitude 20. This is because of constructive interference where point A gets multiplied by 2 effectively in this case, but you're basically just adding the magnitudes of these. That's some resultant vector trickery for you if you were interested in the physics behind it. Overall, I'm pretty okay with how this turned out. I wish if there's one regret I do have with this program is not quite being able to get the sine and cosine functions in C# to work as I thought they should, or thought they would. Or maybe even expanding how my lookup table works to include all of the more specific unit vector or unit circle things, such as how 45 degrees is square root of 2 over 2, etc. The more specific answers, which would have made this a lot more accurate. As if I ran, like I said earlier, the case where you have a 45-degree angle and a 225-degree angle of the same magnitude, which these should technically they should technically cancel each other out perfectly, as they are technically the same. They are basically it's just one inverted against itself. As you see, I ended up with 135 degrees where it should be 0. All of these should be 0. This is due to inconsistencies with how the components are calculated because of sine and cosine being not as exact in C#. But this isn't just a C# problem. This is a kind of computing issue where you don't have enough bits to represent such a precise floating point, double point value in a computer. So there's kind of no solution there aside from purposefully using a lookup table and giving it specific values. I hope you guys at least found this entertaining and or informative. I will see you guys in the next video. Peace.